Okay, so this is the lesson for GCO6 transform figures rigid motions. So before we start, let's talk about what rigid motions are. If something is rigid, what does that mean if it's rigid?
It's hard.
It's like sharp, it's hard. It doesn't move. So what we mean by a rigid motion is that the figures stay the same. So they don't change shapes, they don't change sizes, they stay the same. So what are some rigid motion transformations that make it so the shapes will never change? Like a translation, good. Translation, right, I can spell. Translation, rotation, and reflection. So then what does that leave out? Dilations, very good. Okay, so for these you will need to know what it means for two figures to be congruent. So the symbol for congruent is an equal sign with that squiggle on top. So congruent. So they need to be the same what? Same size. Same shape. So with the same shape, what does that mean has to stay the same? The side lengths. And angle measures. Okay, good. And and then, so rigid motion transformations, they also preserve, that means keep the same, they also preserve relationships. Meaning that if it was parallel, it stays parallel. If it was perpendicular, it stays perpendicular. So it preserves relationships. And if it went, like if one of the triangles, if it went from triangle ABC and it went in that order, then it would stay triangle, but it would be A prime, B prime, C prime. It wouldn't be, yeah. So when you're talking about things being congruent, and if it went A, B, C, the new figure would have to go in the same order, A, B, C. You couldn't say like C, A, B. Like you need to stay in the same order. Okay. So then they're going to give pictures. So one other thing is, like if I were to give one figure, you would have to tell me, is it even possible through a bunch of these things to get it to be the new one? So here's an example. If I had this figure right here, and then I wanted to make it so it went like this. Like, what are some things that would happen? What are some of those rigid motion transformations that would move it from this one to that one? A reflection and a translation. Good. How about, is there anything else that could happen? Rotation and translation. Rotation and reflection. Huh?
If the points were named, you would have less options because they would have to be in the same spot.
Yeah, it depends. Yep, that's a good point. So what she was saying is if this was labeled A, B, C, and D, there would be less options for what you could say if this was instead now A prime, B prime, C prime, and D prime. Because then you couldn't do as many things.
Because for that you could only do reflection and translation.
Yeah, for that one you can only do a reflection and translation. So you just got to watch the details. And then a lot of the questions that are on this part basically are repeating things that you've done in other sections, but it's putting it all together into the same thing. Okay. All right, and then you'd have to look at the other notes that we've already taken. So I'm just gonna go like this. Refer to GCO5 and other notes that you've already taken if you get stuck, and obviously ask me if you're here. So then it's gonna give two figures and you're gonna say, how did it map? So this is called a mapping. So if you map this figure onto that figure, you would have to reflect. And if it was this one that it reflected across, it would have to be halfway between there. It would reflect across that line and then it would translate. And in this case, it would translate down 4. So you just have to describe those things. Okay, and I think that everything else is actually quite self-explanatory. So that's the end of GCO6.